Hey guys, and welcome to Learning Math. Today I'll be going over the Olympiad 13, so let's get into it. The first problem says, each of the boxes in the figure at the right is a square. Using the lines of the figure, how many different squares can be traced? So let's just draw the figure. Here. Okay, so what we can do them is, we can first count the 1 by 1 squares, then the 2 by 2, and then the 3 by 3. So let's just write 1 by 1, 2 by 2, and 3 by 3. Okay, so how many 1 by 1 squares are there? Well, we can do a simple formula. What we can do is count how many is the maximum number. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 1, 2, 1. You can see that they're just decreasing to 1. So, and you have to add them all up. So here's a simple formula. N multiplied by n plus 1, which I explained more deeply in the first Olympiad, so make sure to check that video out if you don't get this correlation. But for right now, let's solve this. Where n is the biggest number. So biggest number 1, 2, 3, 4, 5, which means 5 multiplied by 6 over 2. So 5 multiplied by 6, or 6 divided by 2, which is 3. So 5 multiplied by 3 is equal to 50. So that is how many 1 by 1 squares. Now let's find 2 by 2. It was pretty easy to just count them because there's only 15, and there's going to be less for 2 by 2 because it's expanded or bigger. So what we can do, instead of doing the formula, we can just count them. So, but if it's a really big square like 25 by 25, then you should use the n into n formula first. Okay, so 2 by 2. 1, 2, 3, 4, 5, 6. So there's 6 2 by 2s. So I'll write that here. How about 3 by 3? There's one over here. How about 4 by 4? There's only one 3 by 3 over here. Now how about 4 by 4? Well, there is no 4 by 4 because 3 by 3 is the biggest. You can see, otherwise you have to exceed this figure, which we cannot do. So there are no 4 by 4s. And the question asks for how many squares there are. So we had to add these. 15 plus 6 is equal to 21, and 21 plus 1 is equal to 22 as our answer. And again, if you guys didn't get this concept, the n into n plus 1 over 2, then make sure to watch my Olympiad 1 video, which I'll make sure to leave a link down in the description below. The second problem says, in the multiplication problem with the right, different letters stand for different digits, and ABC and DBC each represent a 3-digit number. What number does DBC represent? 2 answers are possible, give one. So first, let's just write the equation. ABC multiplied by C is equal to DBC, which was the multiplication problem at the right, where the problem said. Okay, so first, let's go in a multiplication process. C times C is equal to C. That's the first step you have to do to multiply. Okay, if C times C is equal to C, basically C squared is equal to C, but with the carry forward, or no carry forward. Okay, so I just wrote the squares. 1, 4, 9, 16, 25, 36, 49, 64, and 81. Now we just have to look at the units digit and see if they both match. Like 9 and 1. Do they match? Nope. 8 and 4. Do they match? Nope. 7 and 9. Do they match? Nope. And then so on. So I checked the ones that match. Like 6 and 6 match, 5 and 5 match, 1 and 1 match. Okay, now we just have to test every potential number that I checked here. So if this was 1 and 1, 1 times 1 is equal to 1. But 1 multiplied by ABC can never equal to DBC because D and A have to be different. So 1 doesn't work. So even though it's a check, the next thing we'll write is X because it doesn't work aside to it. Now how about 5? 5 and 5. 5 multiplied by 5 is equal to 25. So this works, and 2 carry forward. This is fine because 5 times ABC is equal to 5ABC, which can equal to DBC. We're not sure yet, but we don't know any way to figure out that it doesn't work. So let's just continue on with 5. 5 multiplied by B plus 2 is equal to B. So let's write basically B, 5B plus 2 is equal to B with a carry forward or not. So let's write all the numbers here. So 1 times 5 plus 2 is equal to 7. 2 times 5 plus 2 is equal to 12. 3 times 5 plus 2 is equal to 17. 4 times 5 plus 2 is equal to 22. And so on. So 4 being B, 5 being C, and plus 2 is just the carry forward, and the unit digit has to equal to b. So let's check. 1, 7, 2, 2, which matches. So we'll just try to check. 3, 7, nope. 4, 2. So you should notice a pattern here too. 7, 2, 7, 2. Okay, now if it's 7, 2, 7, 2, we already used the 2. Now how about the 7? So let's test that. 7 multiplied by 5 plus 2. Which is this equal to? 7 multiplied by 5 is 35 plus 2 is equal to 37. And if you guys didn't get why I multiplied this first, even though it's left to right, pretend this 7 multiplied by 5 is right here, like 2 plus 7 multiplied by 5. It won't be 9 multiplied by 5, it'd be 7 multiplied by 5 plus 2. But if you guys didn't get this concept, then make sure to watch my order of operations video, which I'll make sure to leave a link down in the description below. But right now, let's solve this. 7 and 7, they both match. So 7 is also correct. So B is equal to 2 or 7. So we use 5 here. Why don't we use the next number, 2? So 2 is here. 5 multiplied by 2 is equal to 10. 10 plus 2 is equal to 12. So B has 2. And 1 of a carry forward. Now how many numbers are remaining? We can write 1, 2, 3, 4, 5, 7, 8, 9. These are all the numbers you can use in crypto theorem. Now let's cancel out the numbers we used. 5, 2, and yeah, we only use those 2. Now we can also we have to use 1 here, because if we use 3, then it's going to exceed the limit of 10, because D cannot be 10, you can see in any of these, unless there's another integer right here, but we don't have that. And it cannot be 2, because we already used 2. How about 1? 1 multiplied by 5 is equal to 5, plus 1 of the carry forward is equal to 6, which that means it works. So 1 and 6. And we're supposed to find DBC, so one answer is 625. The third problem says, consecutive numbers are whole numbers that follow in order, such as 7, 8, 9, 10, 11, and 12. Find 3 consecutive numbers such that the sum of the first and the third is 118. So, as the question says, the 3 numbers I just named x minus 1, x, and x plus 1 because they're consecutive. And x minus 1, the first number, plus x plus 1, the third number, is equal to 118. We could have named this x and x minus 1, x minus 2, but I just named this as x and this to make it a little bit more simpler for me. But you can do any way you like here. So x minus 1 plus x plus 1 is equal to 118. So 1 and 1 cancel out because there's no use of the parentheses right now since this is a plus. So basically x plus x is equal to 118, which means 2x is equal to 118. And we're supposed to find all 3 numbers. So now we can bring this 2 to the other side. Becomes divide. Cancel this. So x is equal to 59. How did I get 59? Well, I just divided this. Now that's only one middle number. So now we can plug it into this equation. So if x is equal to 59, this is x minus 1, the first number, which is equal to 58. So 58, 59, because we just plugged it into this equation. And the third number is x plus 1. So 59 plus 1 is equal to 60. And we can even check this, because 58 plus 60 is equal to 118. That means the answer is correct. So once we box this out, 58, 59, and 60 should be our answer. The fourth one says, when Annie, Betty, and Cynthia compared the amount of money each had, they discovered that Annie and Betty together had $12. Betty and Cynthia together had $18. And Annie and Cynthia together had $10. Who had the least amount of money, and how much was it? So, as the question says, Annie's money plus Betty's money is $12, Betty's money plus Cynthia's money is $18, and Annie's money plus Cynthia's money is $10. And I just replaced them with variables, and they're easier to say. Okay, so C and C are both the same in 2 equations. So what we can do is work with these equations. So I'll write it over here. Okay, now what we can do is subtract them. Because we have 2 variables are the same, we can just subtract them and we'll cancel them out. So B minus A is just B minus A. And C minus C is just equal to 0. So we don't even have to write that. It's equal to 18 minus 10, which is 8. So B minus A is equal to 8. We can bring this B to the other side, or this A. I'll just bring the A. So if this a came to the other side, 8 plus a is equal to b. So now we have a variable that is equal to another variable plus a numeral. So we can also plug this into this. So basically, b was equal to 8 plus a. So a plus 8 plus a, or b, and put this in parentheses, is equal to 12. Parentheses doesn't do much. Okay, so a plus 8 plus a, so which is equal to 2a, plus we can bring this a to the other side and it becomes minus. So 12 minus 8 is equal to 4. Now we can bring this 2 to the other side and it becomes divide. So basically 8 is equal to 4 divided by 2, which is equal to 2. Now we figured out Annie's money, but we have to find the least. So we also have to find Betty's and Cynthia's. Since we know Annie's, then we can plug it into this equation. So basically 2 plus c is equal to 10. Bring the 2 to the other side, it becomes 10 minus 8 is equal to c. 10 minus 2. Sorry. 10 minus 2 is equal to c, which means c has to equal to 8 because 10 minus 2 is equal to 8. So now we know c is 8. So c is definitely not going to be the least amount of monies. So we'll just cross that out to make it more simple. But we also know c is 8, so what we can do is plug it into this equation. So b plus 8 is equal to 18. Bring the 8 to the other side, b is equal to 18 minus 8, which is equal to 10. So b is equal to 10. So now we can also cross this out because Annie's money is less, and we have to also find how much. So the answer is going to be Annie and $2. The fifth problem says a total of 15 pennies are put into 4 piles so that each pile has a different number of pennies. What is the smallest possible number of pennies that could be in the largest pile? So, as the question says, there are 4 piles and there are 15 total pennies. We have to find different amounts, and also we have to find the largest amount of pennies in the smallest amount of pennies in the largest pile. So let's just divide 15 and 4. Or what we can do is find values that are closest to each other. Like, for example, 4 plus 4 plus 4 plus 3. They're closest. So we'll just write that. 3, 4, 4, 4. So 4 is 10, but it's not our answer because we have to find them differently. Okay, so we have to make this the biggest because we have to find the biggest value. We cannot do two the same. So let's just increase this as 5. And they all add up to 15. So let's see if this adds up to 15. 3 plus 4 is 7. 7 plus 4 is equal to 11. And 11 plus 5 is equal to 16. So we have to do it 15. So we also have to subtract 1. If we subtract 1 from here, then what will happen? Then it'll be 2, 4, 4, 5. But two values are the same even though it equals to 15. Okay, so that is going to stay the same. 3. Okay, now how about 4? We can subtract 1, so it becomes 3, and then 4, 5. But these two values are the same. So what we can do is subtract 1 here and add 1 here, because if we add 1 here, then these two will be the same. So if you subtract 1, it's 2, and 3, 4, and then when you add 1, it becomes 6. So these are all separate numbers, so let's check if they add up to 15. 2 plus 3 is equal to 5. 5 plus 4 is equal to 9, and 9 plus 6 is equal to 15, which means it's good. So our answer is 6. Thank you guys for watching this video. If you guys want to watch more math videos, make sure to subscribe to our channel, and see you next time.